white screen Monday. Right. Okay, this is a little thing. It's basically there's something that's gonna be here for everybody. It's we got some electrical stuff, we got some air conditioning stuff. When we got all that one, and Mr. Hart and I just worked on Leslie's dad's vehicle, and what we did was we found out that when we bypassed the relay feeding the compressor, first we took our test light and held it into the hot, hooked it to hot, found out the compressor coil had good ground coming all the way back through it, and then we put power there with the engine running, and the pressure is normalized, and because they had good static pressure, and it started getting cold. So we turned out that we checked the relay terminal going out the compressor, and the relay was energized, but there was no power going out of the relay, so the relay was bad. That didn't take a lot longer to fix. We just moved the windshield washer relay in there, and we took care of that. So that's one of the little things that, it was a quick fix, and we didn't have to have any refrigerant or anything, and we used the relay that he already had. All right, so these systems are changing, and climate control systems used to use 3 to 5 pounds of refrigerant. Now most of them use about a pound. Now here's another little thing while I'm talking. Every now and then you'll run into one that's not dual zone, but it'll like basically, you know, the one that your dad's got is a dual zone because you got cool and warm for both sides, right? But if you got, and those are a different story. But a lot of times you got a car that is cooling really good on the driver's side and not cooling good on the passenger side, or vice versa, it will be low on refrigerant. So always check your refrigerant charge and that kind of thing. But refill capacity is less than 1 pound on a lot of them. Now this right here is an R134YF AC system. And that's the new one that comes out with that really expensive refrigerant that, you know, 10 pounds of it's like $850 or something like that. But anyhow, this is a lot of newer cars are going to have. You might notice that on that one you got an extra heat exchanger, or at least on this map. I don't know how all of them are going to be set up. And then you got your condenser, which you usually have. You got a compressor, and basically you got this extra heat exchanger right here, and then you got your evaporator. So that's an expansion valve is going to be right there. So that is a very unusual thing. Just kind of recognize the fact that the R1234 systems are not going to be just like the other ones. All right, this is your different kinds of compressors. This is a swash plate compressor. That is a fixed angle right here. We'll show you. I got one of those. I actually put in a vise out here one day, if I can get that video to play, and I showed you how that basically how those pistons move in that thing. It's pretty cool looking. And this one right here is a variable displacement compressor. That one, even though it's, you know, looks like it's got a clutch coil right there, most all of these variable displacements ones don't have a clutch coil. They just basically got a pulley with some breakaway things in there, so that whenever you want that compressor to stop compressing, you just change the angle of that plate, and when you make that plate vertical, the pistons aren't moving. That's how that works. And it's basically done with a solenoid and a hydraulic piston that uses refrigerant pressure to do it. And this is a scroll type. You got 2 scrolls in there that are sort of the diametric opposite of one another. It's got seals on either end, and the way that they work together, you wind up, it doesn't take a whole lot of startup stress to fire that one up. The bad part about those scroll type compressors is they like to die. And they used to be pretty high. They've kind of come down a little bit now. Okay, so let me see if I can get this video to play right here. I may have to use my mouse to do that. We'll show you that. And this is kind of, let's see if that'll play. It's got to pull it down from YouTube. I didn't actually embed this video. I went ahead and put it in there. I'm not going to waste a lot of time trying to get it to play, but I can actually pull it up on YouTube and show it to you later. It's really something when you build one of these, you know, how it's supposed to play and it won't play. And that's the great thing about PowerPoint. If you don't actually embed it and put it in the same folder with the presentation, and you're having to pull it from YouTube, you may not get any. But I actually have one of these torn apart, and we were spinning it with a drill, and you see those pistons. I can show you that a little bit later. All right, here's the variable displacement compressors. They use that internal piston. Let's look at a closer look at it. This particular picture is one I took when I was at the MAX convention, and one of these Ranshoe or one of these compressor manufacturers, I don't remember how these things had cutaways to these things. And it changes the angle of that plate once again and all that. And then there's your scroll a little bit closer up. Look. And they fail more than piston type compressors in my experience, although I can't speak for everybody. So what we got here is we got cabin air filters. They've been growing more common since about 1995 when they appeared on the Ford Contour. Here's another thing. Not every vehicle has cabin air filters. My 2006 Explorer I'm driving around now has no cabin air filters. My Taurus did have, and Taurus has had them for a long time. The GM, the Montana, and the vans, you know, the Ventures and all, the cabin filter on those, when you open the glove box, you reach up in there, there's two of them that come out. You pull one out and you slide over, you pull another one out. The Nissan Altima has got a screwball little filter that comes out a little hole about this big, but it accordions down and gets real little. When you pull it out, it's this big. And this parts house may try to send you a little bitty one, maybe want you to put two of them in there or something. But whenever you pull that, you can take that big one you get from the dealer and squish it down, poke it through that hole, and it accordions out. But if you've got low airflow on one, look at the cabin air filter and see if it's all clogged up. That's also a good service point. And all that. So, but anyway, that one there, some of them are behind the glove box, some of them are under the dash. You don't ever, you know, you got to look and see where they are. On the Taurus, they're outside the car. But Ford Contour 95 was the first one that had a 25 micron air filter. Who knows what a micron is?
Size of the filter, like opening, what it lets through.
Yeah, that's a good, that's the size of the opening. But 1 micron is a millionth of a meter, or a thousandth of a millimeter. That's little, isn't it? So, anyway, now airflow control, you know, you got defrost, register 4, inside air max, outside air norm. You might have heard me saying this before, but you will get better gas mileage on a long trip driving on max AC than you will on norm AC, because max AC is re-air conditioning the air inside the car. Norm AC is pulling in from the outside. Have you ever been driving along on norm air and you happen to drive by a field where the chicken truck spreader was throwing fertilizer out everywhere, and you're like, ah, this is terrible because it's coming, you smell it in the car? If you got it on max, you won't have that problem. And I'm going to tell you, next time we have a thing that we'll be talking about, Hyundai has got an air quality sensor. Now, it won't smell a rendering truck with a dead cow in it, and it won't smell the chicken stuff that's getting thrown out of a fertilizer truck, but it will smell diesel and gasoline smoke, you know, like from old vehicles that don't have good emission control. If it smells that coming in the front, it'll actually change it to max air automatically for you. AQS, they call it, air quality sensor. That's a cool thing. But just about everybody today has got electronic air doors, except the Jeep. What operates the doors on the Jeep, the air doors?
You mean like on that
When
one?
you turn the knobs, cables. That old Jeep still got cables on the doggone air doors. Isn't that something? And it's a 2010 model, okay? He's putting a heater core in that Jeep and it's flogging him good, man. You know, I mean, there's stuff that's hard that shouldn't be hard. You know, they got those bolts with the washers going through those holes, and it's out of this off to the side where you can't get the socket on the. It's just hard to explain that, but anyway, that's what you're fighting with right now, isn't it?
Yeah.
The actuator, the S-Class Mercedes has 10 AC servo control motors. Look at all these. Diverter flap, fresh air recirculator, blending air flap, actuator, left side flap, air flap motor, left side vent, right side vent, blending air flap, all that stuff right there. Now, that's really pretty cool on that, and these right here are, as I remember right, they're on a CAN bus. It makes a full circle so that if one side of the CAN bus fails, the other side will still talk. Kind of an unusual thing. I may be thinking about a BMW instead of a Mercedes. That may be awful. It uses stepper motors though. And a stepper motor basically, when you got basically, you're going to be operating these windings one at a time while this thing turns. And it's got a little, they'll have a screw in there or something, and as it turns slow, so it's moving it slowly. It's kind of like your idle air control on your GM and your Chrysler and all that. It pulses ground inputs across the grounds to rotate the motor core in the same way GM and Chrysler air control motors work. And the thing about it is, all of these are exactly the same for every job. But whenever you plug them in, and on some of these systems, I don't remember if this is the one or not, there's little jumpers that are built into the plug so that when you plug it in, it programs the actuator for the position it's supposed to be in. Volkswagens too, like Volkswagens, the ones that I know about, all use the same AC control head. The AC control head being this piece right here, you know, that's got your controls on it. Well, what you do is, when you put that AC control head in there, you got to go in there with your scan tool and say, I'm putting this in a Venegon, I'm putting it in a Passat, I'm putting it in, you know, you're telling it what you put it in, and it knows then what it's supposed to do. That's the way a lot of that goes. But when you plug the actuator and the jumper and the plug set, the actuator work right in the spot that you put it in. All right, so a lot of them, you know, this little bad boy right here is a blend door actuator, like what goes in our Ranger out there. It's in there behind the glove box, sitting in there just like that when you open the glove box. And think about it, it's always remember that, because that's the one, they want to be able to stop the blend door just anywhere and everywhere they want to, so you can control the temperature of the air. Have you ever been in a situation where you still wanted to dehumidify the air inside the vehicle, but you didn't want it to be quite so cold, so you turn it a little bit up towards your red, just a shade, and it makes it sort of tepid. And that's what the blend door actuator is about. Even though all the other, everything else on that little Ranger we got out there is vacuum, this particular item is an electronic blend door actuator. This is some other ones I got here that I was going to wave at you too. That one right there is a blend door actuator. I don't remember what that one came off of. We changed it off of something. Kept coming back off that GMC Terrain, I don't remember. But anyway, there's almost as many different kinds of door actuators as there are vehicles. And so blend door actuators mixes cold and warm air. So some air door actuators are plug and play. You just plug it in, you start using it, it knows, all right? But some have to be learned by the control head. There's procedures for that. Here's your GM procedure for doing it manually. There's a way you can do it with scan tool hoops, you can do it manually. First thing, you change that control head out. When you put the new control head in there, keep your hands off the knobs, right? Place the ignition switch to the off position, disconnect the scan tool, install the module, connect all previously disconnected components, which was whatever, want to do. Start it up and wait 40 seconds for it to self-calibrate. Now here's what it does. It basically sweeps all of its doors all the way one way and all of them all the way the other way, so it'll know where the stops are. And then it stores that information so it'll remember it. It knows where cold is, it knows where hot is, and it's looking at a potentiometer that's built into the actuator so it can do that. So this is an electric thing right here. Now this is kind of what these look like on there. You're going to hear some of these GMs, and this is the most common problem on them, is I hear tick, 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 tick in the dash. Who's heard that? You heard the dash go tick, 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 tick? You can find out usually which one it is by moving the knobs around. But if it's the blend door over there, not the blend door, I'm sorry, the fresh air door on the right side over there, and some of the Impalas and all, we've changed, my goodness, enough of those to start a dealership. That thing gets click, 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 6 all the time. But what's wrong is these little teeth get busted on here. Now, what's the smart thing to do is pull when you pull the actuator out of there, you want to get a hold of the air door any way you can. Like a lot of times I'll have one of this part taken out so that I can stick it down in there and I can try to move that door by hand, because occasionally a pencil or something will fall down in the defroster duct, or some kid will have some toy in there and it'll fall down in there and it'll foul that door. So if it fouls the door is not going to move it so far, then it stops, and the actuator's confused because the potentiometer's saying I'm not as far as I need to be and all that. But anyway, some of them have got a potentiometer built right there, which is like a throttle position sensor. Some of them is built in there a different way, and so on and so forth. That picture was courtesy of Frank Rogers. He worked for General Motors. Okay, now right here we've got HVAC control module, and look at the way these things are wired up. Right air door temperature control, and there's a position signal. See, so this is basically telling it where it's at, and this right here is your control. There's your little logic. You got a junction box right here. So that right there, what's that? Low reference. That's going to be ground, isn't it? All right, and so that one right there is your 5-volt reference. Now, I'm going to show you more about that in a minute, but that's what those actuators look like on a schematic. And that's an actuator like this one right here. That one right here. Now this one right here is great fun to put in because it operates more than one door. You notice it looks like that other one. But you're also going to see 5 little pins in there. And those 5 little pins, if you're like me, you'd think, well, 5 pins, it must have a potentiometer, and it also has got power and ground going to it. Well, that's not totally wrong, but I'll show you something else that you need to know about how to operate these. There's another recirculation mode door. See, that's another little thing. The HVAC control module is what drives that, even if it's just got knobs on it, which is, some of them GM ones have got knobs kind of like this one right here. Let's see if I can back up where you can see that good. All right. So anyway, And of course, you got the blower motor here. Somebody's already had a blower motor in their hand. It's started, haven't they? Okay, and this is an actuator pin. This is only on the GM now. This only applies to the General Motor. You got a 5-volt, see the pins I've got? And you can, these little tiny pins in here, you can see them in there. And that's just a huge close-up of what you're seeing right in that thing right there. All right, you can hold that. All right, you see that? Your 5-volt reference is that pin right there. Your 0 to 5 point position signal, that's actually going to be a variable signal coming out. This one here is not used, obviously there's nothing there. Low reference, 0 volts, that's ground. And then you got ignition voltage and you got your control signal. 0, 2.5, 5 volts, right? So how do we test this? Well, look at here. If you remove the right instrument panel trim end cover, you access the right side instrument panel junction box. See those connectors right there? That's pretty interesting, isn't it? This is only on the Chevy truck, and we're talking, you know, like 99 new body style up to about the mid-2000s and all that, you know, maybe different after that. There's your right-hand instrument panel fuse box, and see how these pins are all numbered here? And that one here is that connector, and that one's that connector right there. These are the 3 you're concerned about, that one, and that one. All right, there's fuse block, right instrument panel connector C5. This is telling you what it does. Light green is your mode door position signal, mode door control, left air door control, left air position signal. So you can actually do stuff like put your meter on there and read that while you drive that motor back and forth manually. See what I'm saying? Come on. And there's another one. See, this is basically giving you what's going on there, you know. And you got a whole bunch of them here. This is the cavities and what they do and all that on that particular deal. I'm not going to worry about that. That tells you which connectors there were and stuff, so on and so forth. Get it, you're supposed to take a 3-amp fuse in a jumper wire, and see if you know what you're doing, you can actually jump it from here to here. Now don't jump, make sure you know which pins you're on and don't jump these randomly. The 3-amp fuse is there for a reason, right? All right, so if you drive your actuator counterclockwise, you're going to take your control signal, and your control signal will be whatever you put right here is going to make it happen. So if you take this, if you ground pin 6, it's going to drive the actuator counterclockwise. And if you take your 5-volt reference and put it to 6, that's going to drive it clockwise. You understand what we're doing here? And we can actually measure the voltage on our position while we're doing this and see if it's able to make its full sweep. You know, you can find bad actuators like that. All right, you got to monitor the position signal with your meter while you're changing position at the controller. So you go to position signal and low reference, pin 7 and 9, and that's going to read what your potentiometer reading about where that door is. It's pretty quick. Get right down to it. Now, monitor your position while driving it counterclockwise with a fuse jumper. Once again, you jump that and that. You can see this thing change whenever you do that. Monitor it while driving the motor clockwise with a fuse jumper. And those words shouldn't be yellow, but all right, monitor it while changing door position with controller or scan tool. You can actually tell it to change with a scan tool and watch the voltage, right? So that's something else you can do. All right, so you can check the status of these circuits, actuator, controller. There's all kinds of things you can do here to find out what's going on. What if you've already changed the actuator and you got a code, your AC's not working right, your mode, and what you're going to be sitting here looking at, oh my goodness, what am I going to do here? Well, you find a bad wire between the control head and that actuator, you'll be able to track that down and run an overlay or whatever. All right, know what kind of system you've got. You know what I mean? I mean, it'd be silly to go in and try to work on a system that's got cable or vacuum, thinking that you're working on that's got, you know, I mean, obviously you're going to do that. If you're not really familiar with the system you've got, you're probably going to run into trouble trying to get it straightened out. Remember what I told you about that. Know whether a scan tool will be needed. Sometimes you have to have a scan tool to, you know, reset the control head and or the actuators. If you're just replacing one actuator, sometimes you got to let it find out where it's supposed to be. If you put a control head in like that pickup truck that your dad's got, have to change the control head, there's a way that you're supposed to make that work. Now your dad's pickup was making a noise when you turned on the blower, right?
Yeah, it was. Because it was hitting the dash.
It had leaves and dust and everything else that had the blower out of balance, and it was shaking the dash. one time Alan Cobb came to me and he said, this Toyota I've got, the dash just shakes something off, and we pull the blower out, and the blower, on your blower, you just pull a little tab and turn it and drop it out of there. It works, it's pretty easy to change out. But anyway, that particular, and that's a 2003 GMC, by the way, but that one had a bunch of crud in there. It looked like an old rotten dish towel.
Wouldn't surprise me a bit. He doesn't clean that. He doesn't clean it out.
Yeah, well, it can get in down in your fan blower no matter what. You can get leaves and stuff in there. Anyway, if it's shaking the dash, sometimes the fan blower can be busted. Oh, here's a good story. We got a blower motor one time. This is not the blower motor we got, but we got a blower motor one time for a Buick. And we put it in there, and it was really noisy, but there was no airflow. Or very little airflow, almost none. It wouldn't hardly blow out a burning match, as a matter of fact. So we got the motor out, and we checked it on the bench, you know, hooked it up, and it ran just fine. Of course, it ran just fine on the car too. But we found out it was running backwards. What's wrong with that picture? Why would it run backwards? How many of you guys have ever known when you get a motor, like you get a fan motor, radiator fan motor?
Reversed, the current's reversed by polarity or whatever.
If you reverse, yeah, well, on this one, no. What happened was whenever they built the thing in China or wherever they built it, they put the magnets in there wrong.
So they put them in there.
Yeah, they put them south and north instead of north and south or whatever.
Yeah.
But we had to send that one back because it wouldn't run the right way. We got another motor just like it plugged in there and it ran the way it was supposed to. This other thing I told you about checking these motors, when you hook a motor up in series with a battery and a light, and you turn it through, you can find a bad blower motor like that sometimes. Also look for these burned up these connectors to be burned where you unplug your wires from it, and also at your blower resistor, where that little resistor that gives you all your different resistances for blower speeds, those things will burn up. I've got several of those out here. I probably ought to be waving one of them in front of you. You know, these things right here, like I say, this is out of a Buick. We have to change those periodically, these things right here. And let me see if I can get that in line. But these right here, you can usually get one that's rebuilt nowadays for $200 or $300. But whenever they were new, they were like $850 or $1,000 for a control head like that.
Move that on.
I sure need to stop that from being there. All right, let's see. Previous. There you go. Know how to read a wiring schematic. If you don't know how to read a wiring schematic, you're going to be in trouble. Basically, and especially you guys that are taking electrical, there's a lot of questions on the electude final about reading wiring schematics, and you're going to be scratching around trying to figure it out if you're not careful. Now you got to know that some actuators are difficult to access. Sometimes whenever you get one, you know, he's having to pull the whole dash out of that Jeep. But sometimes these actuators will require you to pull a lot of stuff that you don't really want to have to pull. By the way, this right here is a blower resistor out of a GM. And that little thing up on the end is a thermal fuse, so that if for some reason the blower is still working. Here's another little short story I want to tell you. Driving along on my way to Savannah one day, just driving along in mechanics clothes, I had to go over for a trip. And I pulled over beside the road where there was this Explorer sitting there, and there's a bunch of people standing around with the hood open looking at it. And so I stopped and I said, "What's going on here?" And this lady says, well, there was a bunch of smoke that came out of the dash, and I stopped and pulled over beside the road. And these people were trying to figure out what's wrong with it. And so I opened the door and I smelled leaves. And I right away knew what was wrong with it. And I said, what you got is you had leaves in your blower housing that got against your blower resistor. And I saw she was running the blower on low, which heats all of these resistors up pretty good.
Yeah,
And she had set, it was laying on the resistor, leaves were laying on the resistor, and it set fire to the leaves, and the smoke came out in her face, and they were looking under the hood for the problem was actually in the dash. And I said, go somewhere and get them to pull the blower motor out and run a vacuum cleaner up in there and probably get all these leaves out of here. You'll be okay. And so just turn off, either run your fan on high or don't run it. But anyway, a lot of times what you're thinking about is just common sense stuff, you know. We initially thought her dad's truck was going to be low on refrigerant or something, but it had 100 pounds of static pressure, And before we pull out and put the refrigerant back in, let's check to make sure everything else is okay. That's when we found our bad relay. The blend door, excuse me, the mode door controls the air output. Mode door tells you whether it's going to defrost, in your face, or in the floor. Got it?
Sir.
That's the mode door. Understand that. All right, now I will tell you that on your all data, it'll say air mode door. It'll be talking about all the doors. The blend door controls the air temperature. Right? I'm saying this because you need to make sure you know which one you're changing. Because if you're having trouble with the blend door and you wind up busting your rear end doing a bunch of hard work to change a door that wasn't bad, you'll be crying in your soup. Know that the max recirc door determines air input source. Also, if you see a fertilizer spreader out there and the stuff's blowing across the road, you better turn it on max or you're going to be smelling all that stuff and it's going to stay in the car. And you'll show up to pick up your date smelling like fertilizer. That's not good. All right. Make sure you're working on the right actuator and don't try to wing it. Okay, who's tried to wing it and got in trouble? You ever try to wing it? Just not look at the book, go in there. And I'm talking tomorrow about, yeah, that's what I'm saying. You can do it. Did y'all get that balance off that Chevrolet motor?
Not yet.
What's wrong? What's happening?
I had to switch around some of the hooks, get it to look just right.
I didn't understand what he said, but it doesn't sound good. Okay. All right.
There's a pain in the rear trying to get it on there.
Yeah. All right. That's the last slide. I wanted to make sure that I made all those points before I got through with this. Give me a second. I'm going to show you this video right here that I had. And
Try putting that piece back on. I have it where the blower goes into. Try putting that piece back on.
what's that now?
I was talking about.
This is just a little piece that go on like to the engine, and it's so hard to get on it. Did you get it?
No, not yet.
You've been trying for like, what, hours?
Boy, I sure messed that copy up. All right. Won't take me but a second to find this.
It's just not wanting to catch it.
All right, right here. This is an air conditioner compressor. We took it apart and we've got it to the point where we can actually watch what happens when we spin it. You notice it's got 5 pistons over here and 5 pistons over here, and they run off a swash plate in the middle. So when we spin that thing, all right, so now that we got pistons going both ways, on each end of this thing, we've got these plates here, and they've got little flutter valves in them. And those flutter valves let it pull in, and then they push it back out. And so that's basically the operation of the air conditioner compressor. See hear my phone ringing? It rings all the time. It rings. Never stops.
It does that.
Yeah.
You're a busy man.